Okay, well, Bruce, I'm going to let you take the lead on starting. You have the deepest experience of any of us on this, and I don't want to do as much talking just because I'm still feeling under the weather. So,
This what we're talking about is the software one, not the hardware, correct?
yes.
Okay. So on the software end, when working with, and I can't speak for the laser cutting so much, that's going to be Ken's, but for dealing with the 3D printing and the FDM and the additive manufacture, a lot of people when they first get started, the only software they really deal with would be Google and web browsers and pulling down files from the internet. That's how most people start, is they'll download files from the internet, run them through what's called a slicer, which we'll talk about, and then send them to their printer. Most people don't start designing things. That's more of a later down the road kind of application. So finding things on the internet, super duper easy. One of the most common sites is Thingiverse. There is another one called Yegi, which actually surfs through all the other servers out there and finds things from different locations. Whichever method people use, it's easy to find stuff and download files. Typically what's downloaded is called an STL, and that's the extension. I forget what it stands for. I should have looked that up, sorry. It's easily Googleable. And it's a file which really just has the movements, locations for where things have to go for a print. You load into what's called a slicer. I'm going to pull up, and there's a bunch of slices out there. Cura is a very popular one. I'm assuming I can share a screen here, so I'm going to do that.
Yeah, see if you can. Cura was by Ultimaker, right? The manufacturer Ultimaker, and they have opened sourced it and made it free for all to use for several years now.
And no, it looks like screen sharing may have been disabled here.
Oh, it may be because we're.
No,
I know you're sharing.
Yeah.
Oh, it is. Okay. All right.
It's attempting to share content. There you go.
It gave me an error message the first time. All right. So this is a slicer. It shows you a print bed.
Now, Bruce, for those of us that don't do 3D printing, what exactly does a slicer do?
Okay, so let me pull up a file to show it, and I'll explain that. Okay, so here is a model. This is a cut up enterprise, obviously, and it's the STL file that's been loaded, and it's really just instructions for where the object's going to be. What the slicer will do, since the FDM printer is laying down a layer of plastic at a time, because it has to lay it on the bottom and then keep stacking and stacking and stacking up on top of that, it's called a slicer because it literally slices the model up into individual layers. And the thickness of these layers depends on various settings. They can be trimmed down to a 20th of a millimeter, which sounds insane. And it's still, to this day, I've been doing this for years, and it still stuns me that this technology works the way it does. So this would be like the first layer, and it would lay down this layer. And we're talking, I've got 0.2 millimeters here. So it's only a 1/5 of a millimeter, but the settings can be changed to a 20th of a millimeter, at least for this printer. And it would lay down this layer that you can see here. And I can, I'll get a not responding. There we go. Try that again. So I'll zoom in a little bit here, make it easier to see. And as we go up, it lays down individual layers by layer by layer. And what the slicer is doing is it is coming up with the code for move the nozzle or the print head from point A to point B on this plane and deposit this much plastic, this much filament. And it programs it in straight lines and curves. That's all it can do, straight lines and curves. And by laying it down layer by layer and stacking it up, it places it on the print bed. There's also resin printers which work in a similar way, only instead of laying down plastic on top of this, then they do light, which solidifies a resin in a pool, and it goes from top to bottom. It's a slightly different technology, but the software is a very similar premise. And there's a
Bruce, there was a comment analogous to integral calculus, slice it and integrate the slices.
just about. And listen, top. One of the cool things about it, though, or not the cool thing, one of the things to watch out for is because you're laying plastic on top of plastic, you have to have a support structure to hold it up. So for example, we get up here on the Enterprise, and you'll notice you've got the main body down the center, you got the nacelle off to the right, and there's the support beam, which goes between the two. Now that would be a huge piece just hanging in space. But the slicer or the model was designed to have this kind of zigzag. You see this pattern right here zigzagging right there. That's called a support. And that support gets built up while everything else is being built up. And then that long rectangle can be laid on top of it. Once it's all printed, you rip the support off and you throw it away. So that's one of the things when designing things with software is making sure that it can print. Having things suspended in space causes print problems. There's nothing for it to hold on to. And that's one of the neat things. I teach my high school students how to 3D print some stuff. And it's kind of it's a physics class. It's kind of an engineering thing. How can you design something in such a way that it has support, it has structure? And you have to think about it when you're actually designing stuff that way.
Now, this is
Have you done any designing work, Richard, yourself with that stuff?
No, not really. I have not done any extensive designing. And now I was going to comment, this is interesting because you have a Prusa printer, which is a brand of printer, and you're using Slice 3R, which Prusa takes the Slice 3R software and sort of customizes it to their printer. Now I'm a Cura user, right? And if you look in the background, that's one of my two printers back there, right? And it's a Creality printer, and they don't put out custom software or software that they've made to prefer their printer. Now I've done some creating of some custom objects, and for that I've done the Autodesk Fusion 360, which is a large learning curve because it is the professional CAD package, right? Now, the other piece for creating that I found that is much simpler, quicker, and easier to learn is Tinkercad. And the thing is Tinkercad is a web-based from AutoCAD, and it's web-based, and it's incredibly interesting because it dawned on me the difference between the two pieces of software. It's not the fact that one is web-based and one isn't. It's the fact that Fusion 360 is standard CAD software, and it is really in the process of building objects, and it is truly additive, right? It makes it easier if you think in those terms. With Tinkercad, it makes it easier if you think in terms of CNC milling, where it is subtractive, right? In Fusion, you create a shape, and then you add things to it, and then you arrange stuff on it. In Tinkercad, you create a block, and then you remove pieces from it, and it makes it a lot easier to use. I was not prepared to do any of those, show that stuff off, but that's where I am weak. And Bruce, you've probably done much more than I have in creating custom objects and things like that.
Well, I've designed probably over 100 different objects.
Yeah, see, and I have not. It just that my brain doesn't work that way. What I've done is I've taken existing objects, modified them, tweaked them, and things like that, right, for some of my purposes.
You mentioned Tinkercad. That is a great starting point. That's where I send a lot of my students. A lot of kids are familiar with something called Minecraft. And Minecraft is, you build cities and stuff with boxes and things like that.
Blocks O resources.
Blocks O resources.
Blocks O rock. Blocks O vegetable matter.
Apparently, there's a plugin you can get that if you use the plugin, you can actually take what you designed in Minecraft and export it to an STL and then 3D print it.
Oh, that rocks.
So yeah, so kids can actually use Minecraft to design stuff. I'm just saying that's an option. But I have used Tinkercad, and I was actually surprised that it was as robust as it is. I've actually done some head-to-head designing where I designed something using Autodesk Inventor, which is the software I use. And I can do stuff there where I'll design it in a 2D sketch, and then you can extrude it, you can wrap it, you can do all sorts of fancy things. It's, your AutoCAD type of application. And I've designed a lot of stuff from scratch in there. But did some head-to-head with Tinkercad, and Tinkercad does a lot of stuff, and it's free. And once you've got your account on it, you can go access it from any machine. So not a bad way to
that's,
go.
yeah, that's the other piece to keep in mind about Tinkercad is it does not take a you know, a $500 computer. It is running on the web, so you're using their their CPU and memory resources, right? It's basically a Java front end running on the web. So I've used it on my, you know, 8-year-old laptop, and it is just as nice as it is on my 1-year-old, you know, pretty much almost current technology stuff. So that's the thing I do love about Tinkercad, but you know, along with its ease of use and learning. Right?
For those on iPads, my school provides the teachers with iPads at our school, and there is an app I downloaded, 3D Design or something like that. I'm looking for it now, and it was actually easy to use. It used the touch interface of the iPad beautifully, allowed you to do a lot of fancy extrusions and wraps and things like that, and it was somewhere I directed my kids to go, that in case they didn't want to use Tinkercad. So there are even just free apps for tablets that can do the 3D design. And the key to all of these is whatever you use, whether it is AutoCAD or Autodesk Inventor or Tinkercad, whatever, they're all going to have their native format. And their native format is not STL. Their native format is whatever, and it'll store it in that format. But all of those programs have the ability to then export a copy as an STL, which is the more of a standard format that you can then load into your slicer. And you mentioned that Prusa has their custom slicer. That slicer works with other printers. I've also got a Raptor printer, and as long as you configure it right, you can use the Pura on anything, the Cura on anything. So they are interchangeable. And they'll have slightly different features and things they can do. And because so many of them are free, it means that the user has the opportunity to download half a dozen different programs, check them out, and see which one they like. Because the best program is the one you can use.
Right. The one you understand, the one that works for you. Right. And I have tried Cura. I did not mess with Slice 3R, and I have not messed with Simplify 3D. Now, Simplify 3D is a cost package, and I will not, you know, I would not tell anybody to shy away from that. It offers some really good stuff. You know, you are getting what you pay for. The free ones are really, really good. And if you really want some of the stuff that comes in the Simplify 3D, you know, rock on, go for it. It is, and then I've used Repertoire. It's a front end for letting you custom control your printer, and it's not, you know, its primary use is not creating models and printing things. Its primary use is letting you test and move your head, move the various pieces of your printer and control them individually, right? And so in tinkering and aligning, fixing, because 3D printing is a finicky hobby. It is not a plug and play hobby still to this day. It is comparatively easy to do, but it's not a grab a printer, set it up and print. Well, I shouldn't say that. Bruce, your Prusa is take it out of a box and it goes and it's successful, right?
Yeah, that is one of their claims to fame, is their ease of use and the consistency of it. You pay for it though. For the build area and the build volume you get, it is a more expensive choice. But I wanted something because when I was new to it, it was my first printer. I had the money, and since I had the money and I wanted my starting in the hobby to be easy, I chose to go that route. And you also had the option of saving $250 and buying a kit and building it yourself. And that's saving a big chunk of change. But I was afraid. I was out and out afraid to build it, so I bought it pre-assembled, and I'm glad I did. Now I've taken it apart, I've put it together, so that might be different. And we'll talk more about that in the hardware section.
Yeah, I don't want to get off that track. Thank you.
Now you had mentioned, you know, the CAD software, and a lot of the CAD software is pretty similar in how it behaves. This would be a design program right here, and this is just a little test piece I needed. But working with them, there's a lot of different programs out there. Some are more user-friendly than others. I like Autodesk Inventor because the menus worked for me. There were some others that I just couldn't work the menus. They were too complicated. But if I wanted to add something to this, I could click on a surface. I could put a circle on it, take that circle. Once I've done with the circle I wanted, I could then extrude and say, okay, great, I want to extrude, have a cylinder come and pop up out of this guy. And now I've got a cylinder. I can change how long the cylinder is. So the menus make sense once you learn what the icons mean and the other things you can do with it. With all the stuff on the top, it's really just, you're not going to break it. You play with it. I don't know if any of you have run into this. I was working with someone else who had designed something and I wanted to improve his design. And I asked, do you mind if I work on this and try and make this cooler? And he said, no, that's fine. I'll send you the code. And the file he sent me wasn't recognized by any CAD program I could figure out. I looked into it and found out that the software he was using was so old school, it wasn't a GUI. It was not a graphic user interface. It was coding. And I downloaded the program and loaded it up, and you were basically writing the G code from scratch. So you programmed the print head to move this many millimeters this direction, this many millimeters this direction, and put down this much filament. And it was just lines of code, and that's what the software was he used to create. And I don't remember the name of it because I looked at that and said, I give up. And, and then I came into this program and I totally redesigned his object in this software. And
Now,
I sent it to him. What was that?
Which software is this that you're showing?
This is the Autodesk Inventor.
Okay, this one
I'm a teacher.
Yeah,
I'm a teacher, so I get it for free. Once I'm no longer a teacher in 2 years, I will be sticking with whatever version I've downloaded. You know, shush, I'll probably stick with it. But it has so many things it can do that I have literally lost track of how many things. All these things are just things I've designed, and this is just a small subset.
Now, I got a question for you that maybe you guys haven't run into, that I ran into on the CNC milling side, is using, now I use totally different software than either of you use. So on the CNC milling side, I started using Autodesk, but that was too complicated for me to get started on. And I've only been doing this a short time compared to you two. But I moved over to Easel and Carveco. But the one thing I ran into is, well, the CAD part seemed to work pretty straightforward. On both of those softwares, I ran into a problem on the CAM part where it actually interprets it to the G code. And the issue I ran into is it is not, even though, pardon me, even though my machine supports arcs and everything about it supports arcs, the G code supports arcs, but it is not translating my arcs into actual arcs. It's translating it into short straight lines.
Mm-hmm.
And well, that's okay for very large projects, but when I'm dealing with fonts and trying to carve a font into a piece of wood, that actually creates jaggies that are visually unappealing to me.
Yeah,
Mm-hmm.
yeah.
And I don't know if that's something you guys have run into, and if there's a different way that I can do the CAD to the CAM part.
It sounds like a problem with an exporting issue because you've got the design here, you've got the arc, the G codes, and this is some of the research I did with G codes, is the G code accepts two commands. A linear command in the Cartesian coordinate system, go from XY here to XY there, or do an arc that has a beginning point here and ending point here and a radius of this. And those are the two codes. But if you're saying that you're getting a translation that doesn't have the arcs, it sounds like it's somehow not going from one program to another program or one format to another format with the arc command, and it's translating it to a linear segments instead.
Right.
And I don't know whether it's the export software or the import software causing the problem.
Yeah, and I think what surprised me is one of the pieces of software I'm using is Carveco, which used to be part of Autodesk. The product was retired and then a third party picked it up and started developing it again. So it's not like a oddball, inexpensive piece of software. It's actually a, part of a larger package, or it was. So I was actually really surprised to run into that particular issue. Now I don't see that at all on the laser side. The curves are and arcs are perfectly fine on the laser side, but no, I was hoping somebody might have run into that. Did I?
Yeah, no. No, there's no, the closest I've got to dealing with ARCs is I have done a couple of firmware updates on my printers. But both of my printers were fire hazards, right out of the box. The
Dude,
original,
I keep a fire extinguisher in my next to my CNC machine.
if you look carefully in my picture, that is a
Yeah.
fire extinguisher
Yep.
in the wall of my room.
Mine,
because of
I likewise have one 3 feet away.
Yeah. So that's as close as I've come because I've looked at option settings within the firmware stuff for the printers. So that's as close as I've come, right? Because there is how the G code gets interpreted and turned into the movements is a matter of how the controller is moving the head around. So I don't know, right? I don't know. So speaking of the we're about halfway through this.
Speaking of safety,
I figure we'll go the hours, the panels are scheduled for a full hour, but we can cut short by a few minutes, just in case, but ours is the next panel anyway. Well, we have to pick up a new Zoom link anyway, right?
it might be.
So yeah, I was going to come on. Yeah, see, yours is all lit up. Mine is not lit up right now.
Okay. Speaking of safety, this is a Octoprint. Printers have the option of having Raspberry Pis, cameras, things like that connected to them, depending on the printer. And this is a webcam down with my printer. And there is also a Raspberry Pi running what's called Octoprint. And it allows me to access my printer through the network. I can look at it. I can see if there's a problem. I'm running another program on this that updates a server on the internet. And it's called the Spaghetti Detective, which is a plugin for Octoprint, which is an artificial intelligence that kind of watches it. And if things get weird, like spaghetti starts piling up, it actually sends me an email and says, something looks wrong with your prints. And if it looks really bad, it'll actually pause my print for me, and then I can remotely resume it. If it just sends me an email that says it looks fishy, we're not sure, I can deactivate it remotely. So there are a lot of software things you can do with your printer besides the designing aspect of it that let you have safety things where you can watch it remotely, that you can turn it off remotely. I think there's ways to actually power it down, aren't there?
Yeah, you can have some, but that's one of the things I did want to talk about was Octoprint, right? For anybody listening who has not done a 3D print before, the tried and true method is SneakerNet, right? You get on your laptop, you take the file that Bruce referred to as an STL, you pull it up in your slicer, and the slicer turns it into the language that the printer can mechanically understand, what we call G code. It is a standard industry standard for decades out in the world of milling and things like that. You put that onto an SD card, a memory card of some sort, and then you plug that into your printer and you go to the little screen on your printer and you click buttons, you tell it, select this file and go, and boom, it warms up and it starts doing its print. Octopi came along, and I found it and I immediately adopted it because I like single board computers and I'm a geek that way. And what this allows you to do is you can now connect to, you hook it up to you put it on your printer, you get a camera, you aim it at your printer, and then you hook it up to your printer. There's a USB input usually there's a USB input to the controller, so you can have the Raspberry Pi, a little single board computer. I don't have one handy real quick. You can plug it into your printer, and what you can do is you can now go over the network and download the print from your laptop to the Raspberry Pi that's hooked to your printer, and your Raspberry Pi feeds the file to the printer, and the printer does what the Pi tells it. And then not only can you monitor your prints, but replay that again. You can get time-lapse captures of your prints. And now Bruce is using a particular time-lapse plugin that gets an image at every time that it changes layer level.
Actually, it moves the print head to a certain location, then takes the picture. That way your
Yeah.
print head's not jumping all over the place. It takes a little longer to print, but it makes for a cooler video. So
Yeah, it makes for a very pretty video. But the things that this does, what this does is this gives you the ability to capture the if you have the camera on there, you can capture the print as it goes and get a time lapse of it, so that if you are having a problem, you can see where it went wrong. B,
right, so
you can monitor.
maybe a support collapse or something like that. You know
Yeah.
what the flaw was. It actually helps troubleshooting.
Yeah. Now go back to the Bruce, if you could please.
Yes.
Go back to the temperature interface.
Oh, you betcha.
Right, because this is what. So these are the things, right? You know, with Octoprint, what you get is on the left is the little where it says auto and things that tells you if the Pi is talking to your printer. As a matter of fact, I can tell you right now, Bruce's printer is turned off because it's. Or was you did? Were you just?
I actually don't. It is turned off. You'll notice the fan is actually in the belts up there.
Yeah. Oh, that's bad.
And the reason, and you'll also notice that the print head is missing.
Oh,
And,
okay.
Yeah, the reason for that is if you look at my camera here, my webcam, there are a couple of pieces of material here in my hand that I have to replace because I was doing some unnecessary maintenance on my printer and I over tightened something. And in my brain, I'm saying, stop it, Bruce, you're going to break it. Don't do this. Don't do this. Stop, 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 snap, and broke it. So that is something we'll talk about when we get to the hardware segment is
Yes.
Yeah.
But so if you want me to share, or if you could go back to the, because what I want to, right, this is what absolutely fascinates me about Octoprint. The other things that it does is not only does it tell your Pi to do things, but it listens to output from the printer controller. And go back to the temperature tab, please.
Mm-hmm.
Right, so you can see that the printer's offline. It's because it says its state is offline on the lower left dialog box, right? But if the printer's on, this on the right hand side, you will get a time graph of the temperature of the head and the bed of the printer. And if for those of you who don't know, they actually are two separately controlled pieces of temperature on these printers. The bed is heated up so that the plastic melts a little bit and adheres better. And the head is what the filament is extruded through, right? And it has to be at a high temperature. But you can watch those temperatures so you can see how your hardware is reacting, right? And B, how different, because different brands of filament will cause the temperature swings in your head, and you can see that, and you can adjust. Once again, the finicky details of this stuff I was talking about earlier, you can adjust your print temperatures for certain brands of filament. And so this is a really good way to watch that. And then if you could go to the control tab, and if you could go to the control tab, this is real time. As Bruce showed, he has a time lapse, but this is real time, right? And so
if I went downstairs and put my hand on there, you'd see my hand waving on the screen.
Yeah, exactly. So this you can watch in real time on the local, primarily on the local network. I don't know if the camera's exported across the internet.
It does it with the that Spaghetti Detective. I can actually view it remotely.
Okay, yeah. See, I tend not to do that. So I didn't. So, and then if you wanted to see some of the other stuff, you can the G-code viewer up there, that tab gives
It actually shows you what's printing as it goes along. It shows you layer by layer. And there's a plugin in here that say I was printing 6 things, 6 parts on the bed, and one of them fails. It comes loose and starts sliding around. I can actually pause the print, tell it quit printing that one thing. And then it says, okay, great. It quits printing that one thing. And then it continues printing the other 5. So maybe if I'm 5 hours into a print job, one thing fails, I don't lose 5 hours of print time. I just flick that one bad piece out of there and continue with the rest of them and then reprint the single piece alone.
Yeah, that's nice.
Yeah, one thing you find out about 3D printing is after a while, you start not caring about the cost of filament. You know, it's 20 bucks a spool. Yeah, it costs money, but most things you print really don't take a lot of filament. So when you lose a print job, watch online, you'll see people say, man, that print failed. They don't complain about the $1.50 worth of plastic. They complain that they lost 8 hours of print time.
Yeah, because that's the other big cost, right? But so to sum up Octoprint, this is a piece of software that I love. Now it requires that you add hardware to your printer. It's the Raspberry Pi, and it's like $30. You know, and it's learning a little more of a geeky technology, but it's worth it in ease and convenience alone, and monitoring ease of mind
Yes.
alone, right? And like you were hinting to, there are all sorts of plugins available for this, and that's one that I haven't done yet. I've got there is plugins that you can use a computer power supply. The 5-volt would supply the Raspberry Pi power all the time, and then the Raspberry Pi will can fire up the PC power supply, and that would be the 12 volts to the printer. So you can now you don't have to power on and off your printer mechanically anymore. And I've not bothered to do that because my power supplies that I have here are server supplies and they're too noisy. And Bruce will talk about that spaghetti detective. If you ever want to talk artificial intelligence, let me know, because I've started down that road. And so I was looking at.
I've always thought your intelligence was artificial.
That's the only way I have it, baby. So, but it is decent. It is reasonable. But it's looking that particular plugin is looking for strands of filament that are out by themselves. So sometimes it can think supports are problematic. Sure. And it'll false report on those. So there's still some tweaking to do for the neural net or the training for that thing. But it's really
I've had a few emails that it was suspicious about, but it has never shut one down falsely.
Okay,
so
cool.
It has shut down some really bad ones, and I went, wow, thank you. But it has sent me a couple of warnings. I looked at it and went, nah, ignore. So far, I've not been displeased.
Yeah, no, Jeff needed that. My friend Jeff was trying to print a Mandalorian helmet, and he lost 22 hours of print time because it's right on him.
That's painful.
It was bad supports, as you alluded to earlier. So, Ken, thank you. Bruce and I have.
Well, you guys have so much more experience. I only bought my machine in March, and with everything going on at work, I haven't really spent as much time on it as I wanted. But I'm more comfortable. I have a CNC, which also has a kit for laser burning. I'm more comfortable on the laser side at this point because I've spent more time doing it, and the software is actually really a lot more straightforward. So as I alluded to earlier, on the CNC side, I use Carveco and Easel. Easel is actually extremely easy to use as long as your machine can talk to it. And even if it doesn't, it'll export everything into G-code. So at first I was even having to get trouble talking to my machine, but I just exported it into G-code, and then most of these CNC machines, the milling machines, come with a program called Candle, also known as Gerbil Control, sometimes called Gerbil Control. And it's just basically G-code to the Arduino unit. That's more your realm than my realm. But to me, it's just black magic. It kind of works and make sure everything's in the right place. I just have one of the cheap Chinese CNC machines that I got off of Amazon for $300 or something. It's the really low end experimental machine. So Easel is absolutely the easiest one I ran into, but even at my limited design skill, I quickly ran into its limitations. It just wouldn't allow me to do things that I wanted to try and do. It was easy, but easy is not always what you want. Carveco I found to be more complicated, and it's the one I'm trying to learn. I am spending most of my time in a program called Lightburn. It's a $40 program. Highly recommend it for anybody using lasers. It is not compatible with some of the CO2 K40 laser machines without doing an upgrade to an Arduino board. But most of the, especially most of the diode laser printers, it should be compatible. And I don't need to do any conversion. It talks directly from my laptop to the CNC machine. Let me see if I can, let me spark it up just to show you what
Yeah, you'd love to see the
Lightburn
interface.
is. Screen share, Lightburn. No, I don't want to upgrade. Did it come up or no?
Not yet. You're just not sharing yet.
Okay.
Check your zoomies.
Oh, there it is. I forgot to hit that button.
So many buttons.
Oh, looks like it's sharing.
Yes, it is sharing now. You are.
Okay, so I will just open up a project. Oh, I should have opened this up ahead of time. Pardon me, I'm not tracking this.
Yeah, no, it's okay.
Good.
We understand you're recovering. This is.
So I'll just pull up here. This is something that I just, as a joke, I made a maker's coin. They don't make these on the CNC side. They make those on the 3D printer sides. So for example, let's move you out of the way. Now, so this screen, for example, allows me to move the head on my CNC machine. So up, down, left, right, which is really important for zeroing out. But for critical parts, what I do is now, this is a very simple one. So it's only a 3-element project, but I wanted each element to be able to carve slightly or burn slightly differently. So for example, this one, I have it's color-coded red here, and it's speed 500, power 30, which means that I didn't want to burn too deep. For the font, I did it a little more power. I don't know why the font needed a little more power, but it seemed to when I was doing the tests. And then the outline, you can see you can do fill line, just a fill, or just a line. And a fill line would burn the contents, plus then do an outline of it. So you get a nice clear outline image of it. And since in this case, I wanted to be able to cut out a circle at the end, I had the last element just do a cutout of a circle. Now I'm going to show you, this is not.
Hey, Ken, do you change the speed as well as the power to cut through material, or do you not need to change speed?
No, that's an important part of it. As a matter of fact, I was just going to show you the other. In fact, hang on, I just accidentally.
It's almost as though you paid Bruce to, told Bruce to ask that question.
No, I wanted to know.
Yeah, no, I'm surprised because that is the difference with the laser, right? With the 3D printing, we really don't have that fine control. You
here it is. So for example, I highlight this cut line. So you can see it's a line. You can see the speed is 500. That's what you were asking about. So this is 500 millimeters per minute. On CO2 printers, that'll be considerably faster. That might be millimeters per second.
Wow.
And then your power is a percentage of power, which is on the right-hand side. You can see that. This also has options, which I am not using, and I don't think mine supports, is minimum power and things like that. I think that's used more on the CO2 side. And here you get a number of pass count. So that's the number of cuts that you're going to do. So for example, on the blue one, I did it in a single pass. The red one I think is also in a single, yes. And then the black I needed to do 12. And this was designed for a 16th inch piece of birch plywood. So that actually was too many passes. I cut through not only the target that I was cutting, but I got a perfect circle on the scratch board underneath.
Oops.
It's okay because it's an aluminum bed. It's not like the laser is going to hurt the bed. It's just that good. You really shouldn't. It's one of those things. It is a problem with the CNC because you break bits if you start hitting the bed.
Is it kind of trial and error with the laser to see how much power to get different looks?
Short answer is yes. And on top of it, it's even worse than that because every order of wood that I get is different.
Oh,
So plywood is for example, plywood's the biggest problem because your veneers on the top and the bottom tend to be the highest grade and tend to burn through very quickly and cleanly. But then you hit a layer of glue, then you hit cheaper wood in the middle of the laminate, and each one will react differently, and it will even from the same manufacturer, it'll react differently from order to order. And so therefore, in general, it works consistently, but specifics, if you're looking for an exact duplicate multiple times in a row, it doesn't always happen. And natural plank is no better because, for example, when I was carving, what did I have? Birch. No, beech. Um, the grain, as you get the compact layers of the grain, sometimes it burns easily and sometimes it doesn't. And so you'll end up with these strange artifacts that you simply accept that because the natural differences in wood are in fact part of the beauty of the wood. So there's nothing you can do about it.
So Ken, now Paula made us threw something out on chat. Take a look at that because, like, the beds you can replace that, and I don't know about with your laser, right? I would imagine that the bed is replaceable at some point as you
Oh, yeah,
if you
the
burn through
bed
it.
would be replaceable, but generally you don't. But you should generally always have a scratch board underneath.
Something right.
Right. And I always, and that goes back to, that's no different than as a photographer when I cut mat board. I always had a scratch board when I was cutting mat board. So it's one of those things that I naturally always do, and it's a good policy.
Now
Uh,
have you? So now you've done basically wood burning. Have you tried doing anything like cutting, um, like thin sheets of Lexan or anything like that? Cutting out there's which you're sharing right now. So right, but there's a great everybody's doing these laser cut stuff with the plastic and like
right.
my
Well,
guy
first of all, let
here.
me let me explain right from the beginning. I use a diode printer,
I
and
s-
this will probably be a important part of the discussion for the next section.
right.
But the diode printer and the CO2 printer lasers work entirely differently. The diode printer is in a visible light spectrum at what, 450 nanometers, where CO2 runs at around 10,000,
Right.
10,002. But what it means is the visible light cannot easily, can't cut clear Lexan. It
Oh.
it doesn't have any way for it to affect it. You can get it to etch it by doing tricks like tape or a coating on it, and basically heats up that.
To absorb the right.
Right.
So the
But you
reason
can't cut it. You can cut colored plastic, but not clear.
yeah, the reason why I'm asking is there different techniques that you have in your software to enable you to do that? Because even like the transparencies, the overhead transparencies, with a diode, you could cut those, but like you said,
Now,
like
having said that, I should be able to, and I haven't. I've actually got Lexan sitting on the shelf that I've been planning on experimenting with. Is there's absolutely no reason I can't get similar effect using the CNC with bits.
yes,
And
that
then I
that
would just
too.
physically carve it away versus doing the laser. And that was actually my plan all along because I knew there was a limitation on the diode side. So in the end, it would be, now it's a total pain because changing out the laser to the milling is about a half-hour process. And so doing a project that requires both is kind of a pain, but that's one of the things I need to streamline. Um,
Yes. So now, have you tried to do any milling at all? And is it easel the same or what was
yes,
Cutio or whatever you called it?
yeah, Carveco.
Carveco.
I've done a couple of projects in easel for CAS, and I've broken a whole bunch of bits because with the CNC side, it's just like on the laser side, although even more so. You have spindle speed, you have feed speed, which is how quickly the spindle moves across the surface, and
Okay.
you have plunge speed, is how quickly and deeply it cuts into the material. And on top of that, you have to carefully regulate the speed as it goes through the material. If it goes through too quickly, you break bits. If it goes through too slowly, then it tends to generate too much heat. And again, you'll break bits, but you'll also run the risk of lighting your material on fire.
Oops.
So it's a careful balance. As a matter of fact, they make it very clear in every forum, you do not run these machines with you not in the room. That's just there are people that set up cameras, but they really don't recommend that. They are adamant that this is a dangerous thing to have.
Yeah, no, I have watched some of the milling stuff, and yeah, no, you can. It is a lot pickier than printing with filament on 3D printers, right? And there is more finesse to it and handling. Yeah, like you said, you're gonna snap bits and you're gonna ruin material.
Well, what I find fascinating is in the CNC world, everybody is desperate for the CNC version of a Prusa, that you can just buy a relatively inexpensive machine that just works. And the fact is, they do have those machines on the CNC side, but my understanding, they start around $5,000, $6,000, $7,000.
Yeah.
And the good ones go starting at closer to $10,000. So for those of us that are hobbyists that are looking for something in the $300 range, we deal with kits, and we deal with, I mean, some basic fundamental things simply are not on my machine at this point. I don't have switches for determining when my machine is at the stops. I have no stop switches at all. I have nothing. It's entirely visual and manual and keeping an eye on it. And on top of it, since I put it together, sometimes the step motors slip, and that happened to me early on. Is suddenly I was running the laser, and it was just burning the same spot over and over because one of the step motors stopped moving.
Well, those printers are in the situation now that the FDM printers used to be, many, many years ago. 3D printers have been around longer than people realize, but they were so expensive that we didn't deal with them. They were only industrial. And then all of a sudden you see one at WindyCon 10 years ago making a little tiny 2-inch tall TARDIS. You go, oh my God, that is the coolest thing ever. And then it made out of plywood, because these early printers were plywood and metal railings.
Yeah, scavenge printer rail.
Yeah, I want
to
answer a comment Paula has made, and
Oh.
it's absolutely true. The difference is those are industrial CNC machines, the $100,000 machines. So, for example, on the forums, I found the forums for CNC very different than the forums for 3D printing. They're actually mostly filled with professional millwrights. These are people that are with 30 or 40 years of experience. And while they love helping the newbies, we are in a totally different world. It is a totally, it's almost kind of funny that they love helping us, but they're also kind of amused at us asking some of these questions that they're like, really?
They're pointing at the toddlers as we stumble and fall.
Yeah.
Right, and giggling. We're at almost 10 till. We could pause now. What did Paula say? The third thought earlier than that. And yeah, and I can't remember. There's there's a particularly foul-mouthed guy on YouTube that I enjoy. It goes by YouTube by AVE, and he is one of the people who picked up one of these less expensive milling machines. It begins with T, and I keep wanting to think Tokamak, but that's like the fusion generator, right? And it's still, $12,000-$14,000, and it's still professional grade, even though it's no bigger than my 6-foot desk here, right? But it's still it's a 5-axis machine, whereas Ken spent $300 and he's got a 3-axis machine, and that's it, right? That he had to assemble himself. So
yeah, the 5-axis is where it starts to get to be really challenging and interesting, but I can't even conceive. I have trouble visualizing how to program 5-axis machines. I at least understand 3, but you start getting into that. That's That's some serious stuff.
Yeah. So I was going to say we could take a pause here and break before we head on into our next section because they happen to put us back to back. We could take a 10-minute break here, and we have to. The link won't be available to the attendees until straight up at 11 o'clock anyway. Is there anything else for you, Ken? Do you want to add or?
No, I want to thank you both very much for
Okay.
carrying this one.
Yeah, no, and Ken, I want to thank you for the idea. You're the one who put this forth for both of these discussion points, and I appreciate it greatly that you had the impetus to help make this, to light the fire and make this happen. All right, we will take a few minutes break,
to find the best tools that are
and I'll take and maybe I'll even like turn on one of my printers for the next one. Both my printers are down or turned off right now, and actually my CR10 is kind of dead in the water.
Yeah, if I turn on the milling machine, you won't be able to hear anything.
And my replacement part showed up last night. It's like, I don't have time to fix this before tomorrow. Dang it.
Yeah, and I'm not going to be able to run a print on my CR10 on my ANET. I wouldn't be able to run a print right now as a demo, but it'd be nice to show people who have not seen it the actual control screen on Octoprint, right? And I can show the hardware in motion.
Yeah, the Octoprint was a little daunting. I looked at it for a while, I wanted to do it, but even with 14 years of computer IT experience behind me, I was really afraid of mussing with my printer and trying to add a Raspberry Pi and an Octoprint, which I'd never played with a Raspberry Pi. And then Jody bought me one for Christmas, which kind of pushed my hand a little bit. It's like, okay, I guess I'm going to do this. It wasn't bad.
Yeah, that's why I said it. It takes some geekery, right? It is another realm that you have to push into. It is a single board computer, which is really a relative new kid on the block in the last decade, much less really kind of the last 5 years. So it's a whole new set of things. It is daunting in that you've got this little bare board computer that you've got to hook things up to just to make it just to even think about it going, much less you've got to create an SD card for it with an image on it and put it in there and bring it up and configure and blah, right? So I get it, man. Right? I'm lucky that I've been in embedded controller stuff most of my career, at least at some user level. That's why it was more comfortable.
Evan's going to shut us down.
Evan's shutting us down.
Okay.
Okay.
Thanks, Evan.
Take 5. Thank you, Evan.
Yes, thank you, Evan. Thank you, everybody, for attending.
Yes, thank you very much.
Let me throw it in here.